Hello everyone. We are going to be solving daily Leetcode problem given on 24th July, that is Thursday, 2322, minimum score after removal of on a tree. Before starting this problem, we shall have a small motivational quote. A man without purpose often feels empty or directionless, so he seeks temporary escapes in pleasures like entertainment, indulgence, or distractions to fill the void. Without a meaningful goal, he avoids deeper reflection and instead chases quick gratification, mistaking fleeting enjoyment for fulfillment. Over time, the cycle leaves him unsatisfied as pleasure alone cannot replace the deeper satisfaction that comes from the purpose. True contentment arises from pursuing something meaningful, not avoiding discomfort through distraction. Okay, so I specifically want to wanted to bring this quote uh, to bring an awareness such that we all focus on our uh, likes and purpose in life. So we all would love to do something. So we should focus on the goal and remove all the distractions and other unwanted activities in our life. So focusing on our goals will eventually give us uh, true satisfaction at the end. So focus on your goals and journeys, right? With that being said, let us look at the problem statement. There is an undirected connected tree with n nodes labeled from 0 to n minus 1 and n minus 1 edges. You are given a zero indexed integer array nums of length n, where nums of I represents the value of ith index. You are also given 2D integer array edges of length n minus 1 and edges I represents a of I, b of I, indicating that two nodes in the tree. Remove two distinct edges of the tree to form three connected three connected components for a pair of removed edges. The following steps are defined. Get the XOR of all the values of the node for each of the three components respectively. The difference between the largest XOR value and the smallest XOR value is the score of the pair. Okay, so we have understood what the score means, right? So that's the definition of score. Now we are asked to return the score of any possible pair of edge removals of the given tree. So that's the problem statement task, right? So with that being said, let us understand more from this problem statement. So, as the problem statement explained, we are not going to go through this explanation here. We are directly going to jump into this example. So, we look at these edges and we form the connected pair. So, we see 0 which is connected to 1. Okay, so I will just draw out whatever edge is there. So, and 1 is connected to 2 and 3 3 is connected to 4 as per the edges diagram, and this has a value 5 as per here. This is 5 1 5 4 and 11. So XOR of these set of values, so removal of these two edges gives us this pair, this tree and this tree and this tree. So XOR of these values, so 5 XOR 4 XOR 11 would give us 10. That is a representation of this. All of these are base 10, so we should convert it to binary value, which would be 1 0 0, 2 power 0, 2 power 1, 2 power 2, 4 plus 1, right? Similarly, this is 4, where we can convert it to 1 0 0, and here this would be 1 and 0 1 1. So this is the XOR, and XOR of this value, XOR operations, I will write, let's say there are two values A B, and result will be like this. So let's say 0 0 0 1 1 0 1 1. So value of XOR operation will be such that if either of the value is 1, then it results to 1. That is, here and here it results to 1, and if both the values are same, then it results to 0. So that's what happens. So this gives a value of 10. That is, let's see, XOR of these two values will be 1 0 0, and XOR of this value will be 1 0 1 1, and we can just have another digit just to satisfy all the all the counts. So this will lead us to 1 0 1 0. This will be equal to 10 in base 10. So this is the value, while let's say the second component has a value 1, which gives 1 only. XOR of 1 would be 1, and XOR of 5, which would be 1 0 0. So this would be 2 power 1. So XOR value of 5 is XOR value of 5 is 5. Okay. Is 5. Okay. So that's another observation. So the highest value here is 10, and the minimum value is 1. So we subtract this, and this gives us the score. So this is one possible way where we have removed these two edges, that is, edges connecting between 0 and 1. Similarly, we should try all possible removal of edges, that is 0 1. We should also try out these two edges, remove these two edges, and this one and this one. So by doing that, we get some score, and we need to keep track of the result such that minimum score of any possible pair of edge removals on the given tree is what we are asked. So to do that, we need to perform some sort of a DFS operation. Depth first search operation, such that we remove pair of edges and calculate XOR of node values of the three split up individual subtrees. Okay, so the DFS function might look like is where we have a node given as an input and a parent, and this DFS function would be helpful to perform few operations such as XOR of the specific node value. This XOR will be a pre-calculated data, or we will calculate all the XOR values of the node specific to the indexes. Uh, and once we do that, we iterate through the neighbors for the node, and we will also have we will also have uh, calculated the graph uh, or the connected node to a specific node and XOR of each node. So these are the two pre-calculations before even coming to DFS. This will be like a uh, this will be something that would be defined outside the DFS function. So going forward, in the for loop, we check uh, we traverse in this for loop we traverse through all the nodes, and we check if we come across a node which is equals to parent, then we simply continue to avoid backward recursion, and we further explore the neighbor node and also pass in the node as the parent value. Just to summarize what we have done so far, we have a DFS function which takes in a node and a parent node. We would always be calculating or keeping track of the XOR of each node value at a specific index through this XOR array. And we also explore all the neighboring nodes that are present with each of the node, right? And we add in this breaking condition just to avoid the backtrack of the recursion to the parent node while we want to go to the descended child only. So we would be doing DFS of each of the neighboring node, keeping track of all the children that can be children nodes that are present to a specific node. And this children node array will be a type of set that it contains array of sets, right? So we will have this outside this DFS function, and once we have all the children node, this would also help us to calculate the XOR of the children, or after we cut out two edges at each after iterating. So the next step after having this DFS function in place would be to calculate the next step would be to calculate a pair of edges that we can remove for uh, for the tree that we have given with the edges as the input. We remove two edges and calculate the XOR value of the three individual subtrees that gets formed, and out of those three individual subtrees we get we need to pick the maximum and the minimum value of the subtree and calculate the score at each point. The minimum of it will be kept track outside the for loop that would give us the result to this problem. So I hope there was a lot of explanation. Please do let me know in the comment section if there is any part of the explanation that was not clearly understood, or the solution approach uh, that I presented here doesn't was not easy to digest, right? With that being said, I will go to the Leetcode editor and quickly start adding in code to solve this problem. So what we are doing here is we are having to create a list which keeps track of all the uh, graph nodes or the edges to a specific node, and we are keeping track of it. It's that we have an uh, we have something similar to an adjacency list where each node would be associated with the subset of nodes. So that's what we are going to do here. And as discussed before starting the DFS function, we are also going to have uh, two set of arrays, one for keeping track of the XOR values of each node in an array of n values, which would initially be filled with 0, but once we have the DFS function completed, all of the values will be populated, and also the children array, which gives us all the associated children nodes for a specific descended children nodes for a specific node, and this would be a array of sets so that no values will be duplicated. And now we initialize the DFS function as per our solution approach. We are going to take in two parameters, a node and a parent. XOR of each node is equals to nums node and for neighbor of graph. So with the graph adjacency list that we have formed, we would be able to get all the neighboring nodes to the specific node, and we add in the breaking condition where if a specific node is equal to parent, then we do not execute further, understanding that it is a parent node and we do not want to backtrack. So we continue. We perform the XOR operation of each of the node with the node that we are given as an input to this DFS function, and also include all the keep track of all the children nodes or the descendant nodes to the specific node. Since this would be a set, we are using the dot add method, and also for each descendant of the children, we add all the descendant and all those also the associated children nodes, if any, right? So this would complete our DFS, and the initialization for the starting call for the DFS function be 0. That would be the zeroth node, and also we give -1 just as a starting initialization to say that parent node is -1 or doesn't exist at the start. Now, once this DFS function completes, uh, we also keep track of the total sort of 0. And now it's time for us to traverse through the edges to and also cut or to remove two pair of edges such that we form three subtrees. So for each edge, we traverse through all the nodes, and this J loop would help us do that. And we use the children array that we have populated and check if it has a node B in it. Then we swap the nodes and just do the operation. So we calculate all the children nodes XOR values, and we store it in the parts array, parts variable that we are defining here. So with each for loop, if we are checking if A has C, then we calculate XOR of C and XOR of A along with the total that we had. So I will write in the formula. Just let me know. Out of the three parts, whichever is the maximum, we pick that, and also the minimum out of the three parts is used to calculate the max and min values out of each part, and we keep track of the min score with difference each time, right? So we only need to return the min score. So that's the one that we are going to keep track. And finally, we can simply return the min score. The only crucial or the tricky part uh, that we need to understand here, and after implementing the DFS, would be with this part where we have implemented this set of for loop, which where we are iterating through each edge, and also we are uh, iterating through the next set of edges to remove two pairs of edges such that we form three subtrees, right? So uh, and also this part of the formula is something that would be slightly tricky if we are not able to understand. So uh, this else part is where we are calculating XOR of A and XOR of C, which it would be the cumulative value of all the descendant nodes. Also, this specific node would contain all the descendant nodes that are connected to the A, and this would be the XOR of A and C. And the third part would be uh, XOR of the total tree that we get to form initially with all the edges, by removing it with the XOR of the C, right? So that's the whole idea. And here, if you see, we are making this part of the logic, we are making the specific node as so let's say we get two nodes A and B from after taking the edge of I, we are setting B as parent to A so that we form a tree, and this gives us two trees. Similarly, we are doing this if there is a child node B with associated with child A, right? Then we are making B as a parent node. That's the whole idea. Uh, and in this case, if there is a child node or two overlapping trees, then we are having to operate it this way, where we are operating XOR of the second tree along with XOR of the second of the two nodes, and also the third part would be total minus the XOR of the middle value. So that's the whole idea. I guess there would be a lot of confusions. I would definitely like to hear wherever you did not understand any piece of solution explanation. I would be happy to help. Uh, the time and space complexity of the solution would be uh, here there is a for loop which is taking about, let's say, n edges, and DFS operation also takes about n operations as we are iterating through all the graph nodes, let's say n nodes. And this is a for loop which has uh, which we are looping over all the edges and also the next set of edges. So it would be at the most n square number of times would be the time complexity, and space complexity would depend on these two parts, where we have graphs which is an array of array, so it would be n square, and also this children, right? So time and space complexity would be n square. This was a hard problem, but I tried to explain it to the best uh, or the simplest possible way. But I would definitely like to hear feedbacks on how this solution uh, explanation was helpful to. So there were few issues before we complete this problem. One is Okay, as you can see, the solution gets submitted. Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.